그랬었길 바랬던 예전 소원 이룬 날 너의 문자 사랑 같은 말 숨길 수 없는 day 고소한 coffee yes we go on and on collect them all but I don't care what they say I like it I go la 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 I like it I just want 사라질까 두려워 fight for it to make it stay just fine yeah yeah I like it I go la 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 I like it I just want oh baby say it and make it a daily prodigy I like it I go la 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 I like it I just want of belief I just cry at my pretty party and I'm getting nowhere while she comes first. How can I get some confidence when my
Okay, good morning everyone. Welcome to join IPv6 deployment section. And this section, actually IPv6 deployment and IPv6 transition will be the key focus from IR community point of view. And that's very strategic move So we try to encourage all stakeholders and all operators share their experience, how they move from V4 to V6, and also introduce any advanced operational technology that can use to facilitate that kind of transition. So we have 5 distinct speakers today, and 1 will be online. And I'd like to introduce the first speaker. He is going to introduce the survey on IPv6 scanning technology and the new target generation algorithm for IPv6 scanning. And the speaker is Ren Gang from the Tsinghua University. Let me welcome Ren Gang.
Good morning, ladies and gentlemen. I'm Gang Ren from Tsinghua University. My presentation topic is survey on IPv6 scanning techniques and a new target generation algorithm for IPv6 scanning. Here are the main contents. Let's begin from the introduction. IPv6 scanning is the cornerstone of next generation cyberspace mapping and the cybersecurity situational awareness technologies. Brute force scanning in IPv4 becomes impractical in IPv6. Even for today's most powerful mainstream global asset mapping systems, comprehensive reconnaissance of the IPv6 internet remain a significant challenge. RFC 7707 provided a summary of the common techniques for IPv6 address discovery. Then how to efficiently detect and discover active IPv6 addresses. The first category involves querying or passing IPv6 address from public resource, such as DNS, IPMap, BitTorrent, and the mailing list. The second category is passive monitoring. This involves collecting traffic or log files at detection points and extracting active IPv6 addresses from them. The third category is active scanning. It's a method for detecting active IPv6 addresses based on seed addresses. This brings us to survey on IPv6 address scanning techniques. As shown in the diagram below, usually IPv6 address scanning can be divided into 3 stages. First is target generation, and the second is probe and scan, and the third is alias prefix detection. And for target generation, it can be divided into 2 categories. First is target generation with seeds. Select a smaller promising set of candidate addresses to probe. And the second is target generation for seedless region, compensate for the limitation of relying solely on initial seed addresses. Alias prefix means an entire prefix that is configured to map to a single network interface. And the alias prefix detection is essential to prevent severely contaminated scan results and the massive waste of probing resources on these deceptive reasons. Ensure more accurate and efficient IPv6 scanning. Now let's focus on target generation. Here is a timeline for the high-level overview of the technologies. It can be divided into 3 stages. The first is early stage, simple, observable patterns or basic statistical analysis. The second is cluster-based stage. Active addresses tend to cluster together in dense regions. The third is deep learning-based stage. Powerful neural network to learn complex underlying structural patterns. Next, let's focus on target generation for seedless regions. The first is manual pattern approach. That's the simple scanning for lower byte or random byte addresses. The second is pattern migration approaches. Take an addressing pattern in one BGP prefix and apply it to another. ADD minor and 6 over are the example for this kind of solutions. The third is the deep learning-based approach. Generalized patterns learned from dense regions and applied to seedless spaces. 6 diffusion and 6 version are the examples for this solution. The next step for IPv6 scanning, address scanning is alias prefix detection. This can also be divided into 2 categories. The first is a density-based approach. Probe a small number of random addresses within a given prefix, and then test the number of response exceeds a certain threshold or not. There are many solutions. APD, 6sense APD, 6tree APD, MAPD, HMAPS APD, and LoRa's are the example of the solutions. The second is a fingerprint-based approach used as a precise follow-up to validate the candidate alias prefix identified by density-based methods. Instead of just counting responses, they analyze them to confirm. BDRAC, UAV6, FAPD are the main solutions. After the survey, I will introduce some related work we do. RGIN, a real-time pattern mining approach, target generation. The motivation of our research is to overcome the 3 shortages of a divisive hierarchical clustering-based method of target generation: pattern loss, lack of real-time pattern discovery, and biased target biased target address distribution. RGIN-based IPv6 scanning system is a closed loop. We probe, and every response address is fed back into our 2 core components. The first one is R pattern, means real-time pattern mining. And the second one is GIN1, means fine-grained dynamic address generation method based on a stochastic strategy. Let's focus on our pattern, real-time pattern mining first. For every new addresses, it generates a set of wildcard-based patterns, a method that inherently avoids the pattern loss caused by DHC's destructive seed splitting. And every new discovered active address is immediately processed by our pattern, generate or update patterns, making it far more adaptive than static batch-based methods. Next, let's focus on GIN1, fine-grained dynamic address generation method based on stochastic strategy. The stochastic strategy means gives every discovered patterns a chance to be selected for generating new targets with probability proportional to their observed success. Agent maintains exploration across the entire density spectrum, leading to much better overall network discovery. Here are our experiment results. Firstly, we get a more higher hit rate to 58%. Outcome outperformed the state-of-the-art methods by 23%. Secondly, balance between hit rate and network discovery. We found 129 new ASs, 1,339 new BGP prefixes, 5 million new /64 prefixes. Thirdly, validate the importance of a stochastic strategy. We include a control group version called RGN about the stochastic strategy. See the bottom two rows of the table. Stochastic strategy balancing high efficiency with broad network exploration. We then do seedless region analysis. Seedless regions means low number of known responsive addresses with a region, such as country, AS, BGP prefix. We have two data sets. The first one is original seeds, the 21 million. And the second one is OCs. That means the original seeds plus the new addresses we found. It's 155 million. The coverage of the existing IPv6 hit list and advanced scanning algorithms is still deeply lacking in these seedless regions. In initial seed data sets, 38.5% of the OAS has 0 known active IPv6 addresses, while in the OCs data set, only dropped slightly to 36.27%. Finally, I will introduce our future work. Our future work main focus on tackling seedless regions. There are mainly two trends. The first is improving seed collection for specific seed regions. Improve the quality and breadth of seed data, not just the quantity. For example, more comprehensive collection of domain name specific to those seedless countries, followed by resolving this domain to obtain IPv6 seed addresses. The second is advancing deep learning for target generation in seedless region, exploring optimal deep learning models and enhancing efficiency. That's all. Thank you for listening and any questions.
Okay, thank you, Rengang. And any other question to this topic? If you have a question, please stand before the mic and say your name and affiliation. So any question? Okay, hearing none. Thank you, Rengang. So I'd like to welcome the next speaker. The next speaker is Bin from VNNIC. He's going to give a talk on IPv6 and IPv6 only and the deployment in Vietnam. Thank you. Let's welcome.
Hi, everybody. I'm glad to be here to tell you a short story about the promoting and deploying IPv6 and IPv6 only of Vietnam. I'm sorry if my English is not good. My presentation has four parts, but I want to talk about, I want to introduce VNet, and then I talk about the Vietnam IPv6 achievement. The part two, I talk about the policy, content, and the roadmap to the IPv6 of Vietnam. The part three highlight the what VNet have done to for preparing the IPv6 only precision. Finally, the outlook for collaboration. First, I want to briefly introduce VNet. VNet is a national internet registry of Vietnam. It in 2000. We are responsible for allocation and management of national internet resources. We also the top level domain .vn. And the third, we are since 2003, VNet had operate VNIX, Vietnam National Internet Exchange. We also run the national DNS structure for the IPv6. VNIX is the national focal for policy, research, training, and pilot deployment of IPv6 and IPv6 only. We also have another other product, other activity for the community for VNIX ecosystem. How about the Vietnam IPv6 adoption? Here are some key reasons. Now there are more than 55% of internet users are on IPv6. Our core infrastructure, VNIX, and SNVN system are fully 100% IPv6 ready. For about the FTTX, now Vietnam has 80% users are already with IPv6. For the mobile network, 88% are IPv6. For the government service, 55% websites are now IPv6 ready. How can we get this result? I want to talk about the national strategy for IPv6. We have many plans, but the first big plan is national IPv6 adoption plan. Action plan for the period from the 2011 tablet nation IPv6 readiness with dual stack. Here are some key reasons. We 2011 we joined the first global IPv6 trial, and by end of 2020, Vietnam has 34 billion IPv6 users. For the 2021 to 2025, we build our IPv6 program. Our objective is fully adoption across the service. the reason by end of 2024, 95 government websites are enabled with IPv6. And what is the next phase for Vietnam? What we are going to do next? Here the plan, our plan, we are going to deploy IPv6 on Vietnam. The IPv6 only roadmap will be announced end of this year. We think this phase is a turning point toward IPv6 only on Vietnam. Why we think we should move to IPv6 only? But for the content, you can see no more IPv4 address worldwide. The same situation in Vietnam. We don't want to depend on IPv4 anymore. Second, you can Vietnam had commercial that 4G, and especially we have a commercial 5G standalone. Standalone is good for massive device ultra low latency, but this requires the native IPv6. IPv4 cannot meet the requirement of massive device and ultra low latency. So we must IPv6 only for 5G SA. Or another thing is, now Vietnam has more than 65% of IPv6 users. And IPv6 now is mandated by sector infrastructure for digital government and digital transformation. What motivates us to move to IPv6? First, IPv6 can meet requirement to connect billions of sensors and equipment. The future technology require global reachability and interoperability. For the IPv6 only, you can see it had the network simpler. We don't use those steps. We don't use IPv4 anymore. We don't use NAT anymore. We get better latency, stability, and especially the higher security. And the key consistent leader in IPv6 of Vietnam paved the way for IPv6 link in our country. From last year's end of the 2024, Vietnam had draft a roadmap to IPv6 only of Vietnam. We start IPv6 only pilots from 2025 and 2026, and then we plan a large-scale expansion in 2027 and 2029. From 2032, we will start IPv4. But this year, we are now considering to accelerate this target. So we try to stop IPv4 in 2030. In 2030, yeah. The draft, the official roadmap we will announce end of this year. There we question what we need have done for preparing for IPv6 only transition. First, for the capacity building, VNIC already built VNIC Internet Academy. This is Vietnam National E-learning platform for Internet resources. There are a lot of online courses on IPv6 and IPv6 only. We designed this platform for government agency, ISPs, enterprise, university, and especially for internet community. The second action here, we have published 2 free technical handbooks for Vietnamese internet community. This can be used in training, deployment, and policy planning. The first one is Mastering IPv6. This book includes theory and practical example from basic to enhanced. The second book is DNS system design, operation, and security. Or we talk all things about the DNS. Here is one of the book we need had published. The third action we need has deployed IPv6 only system for LAN and Wi-Fi user. Our system, the pilot include the router, fiber. We have DNS64 server. We had the XCP server. We use the DNS64 and NAT64 for this pilot system. The result, all the core service like web, mail, streaming work well. You see, the network is very simple, and the performance and security are improved. What is the meaning of this pilot? With this is our early IPv6 only pilot in Vietnam. This provided us the experience to refine the national roadmap at talk and support. And we hope we can support other organizations to train to the IPv6 only. VNIC also build a public DNS64 for other organizations can try the IPv6 only. Yeah, the outlook and cooperation. Here our recommendation. IPv6 only is the foundation for the sustainable, scalable internet future. The second is we call on ISP, can provider government should begin the IPv6 pilots in this year and next year. We need always strengthen partnership with APNIC, IR, other NIR, and global operator to share expertise and best practice about the IPv6 only. And we hope to develop a complete IPv6 only ecosystem in Vietnam. I want to conclude with 3 key messages. First, IPv6 only is the national priority in Vietnam digital strategy. Second, we want Vietnam to be the forefront of IPv6 only position in AP region. And we need commit to act as a hub of knowledge, training, and support for internet community. And here is the closing message from my presentation. We IPv6 only, we turn the vision into the reality for the future of the internet. Thank you for listening.
Please remain for a little bit. Any question regarding to this topic? Okay, Irina, thank you very much, Ben. Thank you. Okay, next I'd like to invite Jeff Houston, Chief Scientist of APNIC. He's going to give a talk on measuring the transition and what the data tell us about the IPv6 only adoption. Let's welcome Jeff.
Hi all. 15 minutes, right? This is going to be quick. Slides here. Next slide, please. I'd like to actually cast your mind back to about the time before most of you were born. Because at the time, computers didn't fit in your pocket. They were not small. They were excessively large. Fax 11780. Notice it took up 5 racks. Single disk drive was the size of very large. But the interesting thing was the network was actually incredibly simple. It just shipped packets. Everything else was actually done by these attached mainframe computers. The original internet design was incredibly simple, incredibly dumb network, all the functionality provided by devices at the edge. When we started to roll out volume, the reason why we wanted volume wasn't because we were building more mainframe computers. They cost millions of dollars. We weren't building a lot of them. What changed the world was the original desktop machines, those personal computers, which became phenomenally popular in the 90s. Now, the issue was we stopped building telephone networks, started building segmented networks. And we made a distinction between servers at the edge, those desktop units, and services in the middle, and divided the network into clients and servers. We actually had functionality inside the network, which was quite novel at the time. The naming system, we call it the DNS, network function. The routing system, network function. And even content and messaging services became internal to the network. And so we built this kind of asymmetric network where the network actually had some functionality built in, and at the edge were just dumb clients. We've perfected that over the last 20 years. And the conversation about technology and the internet includes all of these subjects and more, that we've managed to specialize and create more and more distinct areas of application, be it data centers, quality of service engineering, even that rubbish called MPLS, it's all over the place. Not the least of which is also the whole area around mobility and trying to do the internet over radio. But there is something that's constant in all of that variation of technology, because they are different networks, very, very different. And if we'd been building it in the 1980s, we would have built a different family of protocols for each network. I don't know if anyone is older than me in this room, but those who are might remember that when Ethernet first came along, we had a whole family of protocols and applications that only worked on 10 megabit Ethernet and didn't work in any other context. We were used to customizing for the network itself, for each type of network. The power of the internet, the genius, was that one protocol, one technology could straddle all of these different media. So we introduced ATM, we introduced FDDI, we introduced fiber, we introduced data centers. Each of those revolutions of change, we just mapped the internet onto it and it just works. So the thing to look forward for, and the reason why V6 is a topic, is to think about what's coming, not what happened. And what's significant in those coming decades is a really fascinating question. First thing, the guys in the optic labs have been working overtime like crazy. They have exceeded their KPIs like no one ever thought possible. That we've managed to now stuff terabits of capacity into a single piece of fiber optic cable. Are we using better lasers? Not really. What's the trick? Oddly enough, the trick is actually at the other end. It's better signal processing. Those DSPs, those digital signal processors, the more capability gates we can ram into a chip, the more we can extract signal from a really lousy sort of signal that comes out of the fiber. And now we're looking at inside a single cable with a number of different wavelengths, anything up to 3 to 4 terabits of capacity. Capacity is not scarce. I'll say it again because it's really important. We're in abundance. The network is not screaming out for bandwidth. The network is overflowing with bandwidth. There is so much capacity, and this is novel in the world of computing. We've never been here before. Over in the silicon chip factories, over in Taiwan, which is the heartland of now 2 nanometer feature chip technology, using chip fabrication engines built by the Dutch, Philips. That combination has produced awesome capability and compute power. Apple's latest announcements in their chips are getting close to 1 trillion. That's it, 1 trillion gates on each single chip. Compute power is not scarce. This is a supercomputer from the 1980s. And it just simply seems to be going up and to the right. And last and not least, there is no shortage of storage, absolutely none. With solid state storage all over the place, we can afford to put the latest copy of every single movie ever made in data centers 2 kilometers from where you are for every value of you on the planet. Storage is abundant. So all of a sudden, the drivers that's driving this communications enterprise have radically shifted. In the 1980s, it was all about rationing scarcity. Today, it's all about abundance. And abundance has changed our delivery model and the models of protocols that we use. What we've been able to do is to get rid of distance. If we can actually make the source, the server, close to you, then we can actually make much, much bigger networks. 5G matters. The fiber optic systems we're deploying matters because all of a sudden we can make networks that can literally deliver 1 gigabit per second of data to anybody inside that service zone. The current rollout of broadband isn't broadband as kilobits, it's broadband as gigabits. And we've achieved this by serving from the edge. Serving from the edge also eliminates distance. The faster you can make that interaction in flow control, the faster you can push things. And what's actually happened here is that edge-based systems have got phenomenally faster because they're shorter. If you think of the amount of distance the packets you consume to watch YouTube videos have traveled, they haven't traveled around the world. They haven't even traveled across most countries. They've certainly traveled across the city to get from the data center to you. So all of a sudden, we're now talking about much faster networks, and bigger and faster is cheaper. You're paying a whole lot less than you were paying for a telephone 40 odd years ago. So those 3 factors basically going, the communications industry has changed like crazy, but we're reaching some fundamental limits. And one of them is actually in processing. It's actually it's getting slower. Why should we be concerned about that? Well, we might not be packing more gates into these chips, but we're certainly making more and more and more. We have to, basically have a network that continues to grow. But if we don't have processing capability growing at the same rate, we've got a problem. Because when we look at things like addresses, and V4 in particular, there was a limit, 4 billion. But you go, oh, 4 billion, that's enormous. How many chips do we make every year? Clue, a lot more than 4 billion. So there's kind of a problem about we're making more devices that want to connect to the network, then in V4 we had networking capability to do it. So the infrastructure demands far exceeded the number of car license plates on the roads. You know, we had a problem. How do we actually change that? We added more processing into the network. So we enabled NATs. We did a whole bunch of tricks inside the network to make it scale. So if you're now a large scale deployer, Amazon, Google, Microsoft, then you can't do it on just V4 alone. You've got to do all kinds of tricks in terms of trying to cram enormous amounts of capacity into that system with not enough addressing. And what if you still want to scale? Well, you've got a few other choices. You're kind of forced into complementing V4 with V6. And the last, I'd say about 10 years, we've finally got serious about dual stack, not V6 only, dual stack, complementing V4 with V6. And that's kind of an obvious response to the question. Hello, next slide would be really good. AV, advance the slide, please. Thank you. So some countries have felt it more than others. The folk who got there last, who were slow, but had enormous amounts of population to cover, had the biggest problem. The early adopters had heaps of V4 space, never saw the momentum to move to V6, probably never will. They're quite happy on dual stack and nothing's going to change. India could have never done it with the few V4 resources they had. So you saw in the period between 2017 and 2020, when India did a massive deployment based on mobile devices, that all of that was done with basically a V6 underlay. And on top of it, V4 was loaded as the payload inside the underlying V6 network. And that explains a fair deal of the growth factor in the last few years. China, very similar problem, very similar population and a late adopter. And by the time they started to get serious about scaling, the V4 pools just weren't big enough to sustain it. So that explains why. But we're looking forward. Where's this going? Well, nothing's left in the network anymore. Everything's moving up the stack into applications. The network's role is simply end-to-end transmission again. It's a throwback to the 80s. All that service mediation, we've got abundance. There's no point in QoS. There's no point in rationing. So applications become the service and the currency of today's networks. What does that mean? Well, we're now simplifying networks to scale even further. A simpler network lets you scale at much, much lower cost. And now we're scaling at the edge by replicating content as close as possible to every single user. And we used to tile that together with coherent addressing. I have one address. No matter what I try and do, it's that address and that's what I use. That's the 1980s model of networking. The problem hasn't changed, but the scaling has. And we're not doing V6 everywhere. So how do we tie it all together? And the answer, oddly enough, is names. I have my content hosted on Cloudflare. Why? Because I'm cheap and they don't charge. Here in Da Nang, when I go to my website, my device has an address, my website has an address, and I see my website. I really don't care if it's V4 or V6, they just have addresses. When I fly back to Australia, I can still see my website, but I have a different address and my website is delivered from a different address, but it's the same website. How do I know it's the same? Because TLS told me. How does TLS know it's the same website? Because the name is constant. Our entire security fabric of the internet is based on names, not addresses. Addresses do not have permanence. Wherever I go, I get given a new address as soon as I land. Even in the plane, when I'm on a satellite connection, I get a new address. Addresses are not permanent. Addresses are temporal. Names matter. And in the longer term of the network we're looking at, all of those theories about name-based networking are now coming into reality. If you really want to scale this further, and we do and we will, we can't do it with addressing alone. Addresses simply stop the packets getting confused. What keeps the full scale of the network running and scaling further is actually the name system. Like it or not, the DNS is now absolutely critical to all of the systems and services that we run. And the security of the DNS is an order of magnitude more important than anything you might think about the security of routing. In short access-only networks, there is no routing. Doesn't matter. Even address integrity doesn't matter. But name integrity matters like crazy. So the whole underlying fabric is now not about the topology of addresses and connectivity, it's about the naming system. The new BGP for tomorrow's internet is the DNS. We've removed the pressure from the transition to V6. Why is this taking so long? Because it doesn't really matter. ISPs who are doing it slowly aren't making less money than ISPs who are doing it really quickly. V6 is not an imperative. It'll solve a problem if you came in late and don't have enough V4 addresses, absolutely. But it's not essential for those who have already been there for a while. Dual stack is doing just fine. There's no pressure because the names are carrying the entire load. So if scaling is your problem, and it is for all of us in this room, V6 has a role, and it will continue to have a role. But that service level scaling relies crucially on the coherency and integrity of the naming system more than any other thing. And that service level scaling is what is absorbing this industry's attention as we move forward into the next decade or two. Thank you.
Okay, thank you. Any question to Jeff Houston? Very interesting talk. Any question? Okay, hearing none. Thank you very much, Jeff.
Thank you.
And then next, I'd like to invite Fan Ting Hui from VMPT. He's going to introduce IPv6 for 5G, IoT, and industrial internet. Let's welcome.
Good morning, ladies and gentlemen. My presentation today is about the IPv6 for 5G and the industrial internet. My presentation will briefly review about okay. My presentation will briefly review about the reason why we need IPv6 for 5G and industrial internet. Next, I will tell about some solution to implementing IPv6. Next, I will show you about some case study in the world and my experience to deploy IPv6 on our existing network. And the last is my suggestion based on our experience. Now, let's go. First, why we need IPv6. So we will review about the recent years. The 5G is booming. Okay. You can see on the report. Now we are having more than 3 billion 5G device in the world, and the forecast to 2027 in the world will be more than 4 billion device, and forecast to 2030 more than 6 billion device in the world. And about the statistics in Vietnam, in the July of 2025, the third, the three largest IS mobile operators in Vietnam have more than 11 million 5G users. So you see, that is the very large number of the demand of IP address. So next we will review about the IoT forecast to see how we really need the IPv6. Recently, we have the term industrial internet and basic and common definition that the industry internet is the ecosystem of interconnected device, sensor, and other machines with highly autonomous and without the human intervention. So briefly, we can understand that industrial internet or industrial IoT is the combination of IoT and cloud and big data and AI industry. So the IoT forecast we see here. The forecast of IoT device until the 2027, there are nearly 30 billion device in the world. Oh, so that is a very huge number, and the growth speed is very high, nearly 20% per year. Okay. In Vietnam, the Deloitte forecast to 20 and 27, there will be 15 million IoT device in Vietnam. So now, I think that most of us will agree that IPv4 is really not enough for the IoT and 5G ecosystem. And the IPv6 is, of course, indispensable for 5G and IoT. So next, we will move to the solution to deploy IPv6 for 5G and IoT smoothly. As you know, in the past, we had some solution to deploy IPv6, but until now, I think that there are only two most common solutions. One is dual stack, and one is IPv6 only. And each solution has disadvantage and advantage. I will show you the advantage and disadvantage of each solution, and what will be the long term for us. You know that the dual stack will be very smoothly. Oh, oh, it's not single. Okay, you know that dual stack is the quick win solution to deploy IPv6 quickly. In my experience on our existing network, we deploy the IPv6 from 20 and 9. So in our experience, we remember that almost of our IP transport network no need to change. We only have to make the MPLS tunnel to transport the IPv6 data. The only we have to configure is the IPv6 on the BRAS and IPv6 on the ONT of the fiber network. But the most disadvantage of this solution is that we still have to remain the IPv4. We have to remain the CGNet, because you know the dual stack still using the IPv4. So if we if we keep the dual stack, so so it means that we still we cannot turn off the IPv4. So I think that dual stack is an effective transition solution, but not a long term. Next, we move to the IPv6 only solution. IPv6 with the IPv6 only solution, the network architecture is very simple. We don't have to maintain the two protocols together, and it will reduce the network burden. But if we deploy the IPv6 only, we have to, for example, we have to may have to pay the money to upgrade the network, to upgrade the end device for customers. But if we follow the IPv6 only, in the future we will smoothly move to 5G SA, because IPv6 only is natively support 5G. So I think that it will be the long-term solution. And now there are many ISP and many countries has released their own plan to deploy the IPv6 only. So let's go to the some statistics from a report from IETF. Nearly 50% operators now using dual stack, and the IPv6 only now is mainly deployed in the mobile operators, because I think the mobile operators network is quite simpler than other ISP with the both fixed and mobile service. So it's very, I think that is quite easy to deploy IPv6 only in mobile operators. So you can see in the examples of operator deploying the IPv6 only, most of them are the mobile operators. For example, T-Mobile in US, Telstra, NTT, and China Telecom. Some countries that have announced the plan to move IPv6 only, there is the US, Germany, Czechia, China, India, Malaysia, and Vietnam. And I saw that most of them release the plans that around the 20 and 30 to move to IPv6 only. In Vietnam, our government also released our IPv6 plan. In 20 and 30, we will start to turn off the IPv4, and in 20 and 32, all of Vietnam network move to IPv6 only. Oh, that's quite, I think, that's quite not so easy. The next I will explain why. In our company, we have released our own plan. I will say you about some milestone of us. In 2016, we launched IPv6 for FTTS subscriber, and in 2018, we are the first operator in Vietnam launch IPv6 for mobile user. Now, currently, our transport network IPv6 ready 100%. But now, because of the end device of subscriber, until now we have more than 75% FTTS subscriber and 89% mobile user and 100% IDC infrastructure IPv6 ready. And we plan around 20 and 30, we change all of our network, all of our service to IPv6 only. Next, I will show you the current IPv6 deployment in the world and the reason of the difficulty of the IPv6 only in the short time. From the report of Google and Facebook until the September of 2025, in the world, only nearly 50% user have IPv6. And here is the ranking of top 20 IPv6 deployment countries. You see that only France, India, and Germany have the percentage more than 70%. Other countries around 50%. Why? Based on our experience when we deploy IPv6 for our subscriber, we realize that the key factors affecting to the IPv6 adoption. Firstly is the business, because some developers, some ISP don't see the profits, the revenue from the IPv6 deployment. The next is the content. The content. Many websites only support IPv4, not support IPv6. And next, I think that is the most important reason is the manufacturer and many types of device. For example, for the Apple device from the iOS version 9, they enable dual stack by default. But for the Android device, the story is very different. From the report, we see that the nearly 20% of Android device now using the Android version from 11 to below. You know that from the Android version 12, the dual stack is enabled by default, so it's very easy for the user to use IPv6 on Android device and Android device version 12 up or upper. But the story in the Android version 11 is very different. We have to manually enable the dual stack in the APN setting of device. So, but not any users know this. So, and the and many device support the Android 11, but Android 11 now is end of life, so it's no more support. So it will alive on our network for a very long time. So it will be the key factors affecting the IPv6 growth speed for the end device. And there are many types of IoT device and IoT manufacturer. We cannot, we are not sure about their IPv6 support. And the last is our suggestion based on our network experience. First, I think that from the policy, the government the government should mandate the IPv6 transition roadmap for the firstly for the government agencies and for the major ISP, and next we should make the ecosystem around the IPv6. We maybe encourage the IPv6 development. For example, reduce the tax or reduce or reduce the tax for import and export IPv6 device. And next, we should raise the awareness of IPv6 for the public. And the last, I think that we should make make the expert familiar with the IPv6 only to train them to get the knowledge of IPv6 for the long-term development. That's the last slide of my presentation. Thank you for your attention.
Hold on.
Thank you. And any question to the speaker? There is none. Right. Thank you. Thank you,
Thank you
Pan.
very much.
So the next speaker will be present online. Can I check, is Luke online ready? Is ready? Okay. Thank you. Let me know if.
Okay, is that working?
Okay, the next speaker was Luke Thompson from the network crew. He's going to introduce cPanel IPv6 overhaul, easy v6 for the millions. If Luke, you are ready, let's move to you. Thank you, Luke.
Thank you so much. Hi, my name's Luke from TNC in Merlot. We've done a whole stack of work over the last couple of years to get IPv6 rolled out internally and taking the opportunity to use that as a chance to enable the cPanel and WHM products to let people deploy IPv6 with less friction. So if we're going back over 10 years now, they did actually put v6 in the product back in 2013. But their logic internally was that you would need a shared IPv6 address for the machine. And you would also then need a separate range just for issuing out to websites. Now, the issues came because you could not have the range nested within the shared v6 or vice versa. It had to be fully separated and isolated, which in a lot of instances was really not going to be working. Typically, you just get the one set or you get just a nice range. But even here, if you were to try and chop it and set them separately, the system wouldn't have it. So we tried to work with cPanel on and off for about 7 years. And in the end, we started to make some progress. So v6 had been around for 3 or 4 years inside cPanel. And they had this concept that you would be assigning a different address to each of the services running on each of these systems. So you'd have something set up for HTTPD, you'd have something set up for your SMTP server and so on. And based on that internal understanding, that led to a lot of these decisions and changes. So they decided that they would try going with allowing the shared address and the range to be together or to be nested. But back then, with all the software versions running quite stable or LTS, it caused some problems. It broke networking and they got rid of it. So you join us at now, where we're looking at cPanel versions 126, 128, 130. And we're sort of seeing a bit of a paradigm shift, really. You've got major providers like SiteGround who since the acquisition, since Nick got out, have decided that they're going to make their own platform and shift over to that. You've had some people that, just want their account manager back, whatever it may be. But what you can't argue is just how widespread this software is. And in our perspective, it was a real case of you've got something that makes an experience simple and straightforward for the masses, and you're not making it simple and straightforward to at least go dual stack. Because cPanel still doesn't let you remove v4. Hopefully one day they do. But at least now we are finally back to a point where you can combine everything together. It does work properly, and you can follow the KISS principle. So on the note of that, our methodology with a lot of things is simple systems designed well can do a lot really efficiently. And having had some experience with the cPanel team in terms of trying to get things done, it also felt like the KISS principle was really valid there in terms of, shall we say, commercial acceptance to get the changes pushed through. Now, we had some very interesting conversations where it became quite clear that the understanding isn't really there. And I'll be the first to admit that I'm not particularly across the nitty-gritty detail of everything, especially in the networking space. It's been a real learning exercise for me. But we did reach a turning point where cPanel or WebPros explained to us, look, we don't understand IPv6. And based on not understanding IPv6, we don't really know how to change it without causing problems and to improve things. How do we even test it? So that was a real turning point for us, because we'd already been working with the technical assistance platform and some of the legendary people there at APNIC. Terry, Dave, and Zobera, the key ones who were just incredible at helping us get this all done. And in working with them and having that confession, if you will, from cPanel, we were able to go a bit deeper and stop all of the questions about the little details and just focus on what can you do to get rid of this problem and get it back to how it used to be, and how can we help you get that through. So when we made the move into NextDC out of Equinix, we did a network build, and I would say, and Terry's probably sitting out there somewhere putting his head in his hands going, oh boy, but we had a bit of a situation. So we were already working through, say, the trenches there to get all of that organized. And it's a long journey in from the countryside here to the data center. So we're doing a lot of combining changes on the core routers, changes in the switches, changes in the hypervisors, Proxmox, alongside all of the prep for IPv6 with cPanel. And we also have to keep in mind that we've got different factors at play. So we also have the fact that we've never actually had it working properly. We've had, one direction okay, but bidirectional, no joy. So we knew we had larger problems, and also simply could have been the case of things right in front of us and we just don't know where to look. So we sort of stripped it back and understood what are the weaknesses in how we've got this currently built, what are we trying to do with it, and then from that, how can we line it up so as cPanel are fixing things, we know that the network is solid and it kind of all merges together. So Global Secure Layer gave us the okay that everything's good. We then reconfigured eBGP, we added iBGP, we shifted from OSPF to VRRP, and we sort of restructured our prefix usage as well. Now, this took a lot of chasing, a lot of nudging. There's some SMSs there with Terry once it was done of, what's happening with cPanel? Yeah, are we going to get this done? Are we going to push this out there and let people know that it's sorted? We were on fortnightly calls at one point and just chasing and chasing and chasing to get these quite tiny changes made. But as they get more commercial and expensive, the time for the real engineering seems to kind of go by the wayside. So our goal from day one has been to be advocates for V6. I really dislike the kind of approach or aura, I suppose you could say, that V6 comes with some people. Some people love it and advocate for it, and those people are fantastic, but there's still this, I don't want to do it. If it ain't broke, don't fix it. Whereas our view is if we build heavily into V6 early, we're not giving ourselves baggage. So working with them, I think they were getting quite sick of us by the end, but we were jumping on calls, we were getting everything organized, we were testing early release builds to make sure things were okay, finding bugs, sending them through. And this is kind of what that looks like over the last couple of years. Now, that earlier one for their wrapped up Nginx reverse caching proxy setup, that case was years old. And at one point, they kind of abandoned it. They finally got it in. And then you've got the second item there to actually allow you to configure the shared address and the range being the same. And then once that was fixed, there was still some leftover kind of scraps, warnings, you can't have this there, even though it was okay. They got that fixed and we're left with just one curiosity where if you restart the network card that's got all of these resulting issued /128s, it will drop all of those aliases, which they say is by design. Why they can't just do a hook registration, I don't understand, but you do have to run that separate thing anyhow. So this is now out. It's live for everybody. It's on stable, it's on long term, it's any branch, you'll already have it. So if you've been holding off, if you've been delaying, if you haven't been too sure how to do it, there's no stress. You can cut across without impacting your V4. We would recommend going for a dual stack approach. You can just keep it on a shared address. You can use the ranges, but the key thing is you don't need anything overcomplicated. It's all just straightforward. Now, in terms of trying to cut a lot of space into tiny chunks of space, and at the same time, trying to be very mindful of good V6 design and remembering a key conversation with Terry where he effectively said, look, all of your learning and understanding based on V4, great, but in the context of V6, you have to forget it. Completely useless here. That was a learning exercise, but then, everything as a prefix was a learning exercise, but then starting to understand the links between the different layers was also really helpful. And like I said before, this is outside my comfort zone and has felt kind of gate kept a little bit, which is where I'm really grateful to Terry and Dave and Zubair for breaking down that wall. In that we wanted to understand it and do it properly, but not just get it engineered, actually understand the engineering, the why, the how. So that's really key for us. So we've taken the /32, we've cut that effectively 3 ways to get a customer section, a corporate section, and an out-of-band section. And then within that, we're using that 5th octet, which you can see there as food, as a location, like the data center. And then that 6th octet is your machine ID. And then that /96, the start of is your shared address, but you can then issue inside of per site and get things like forwards confirmed, reverse DNS, and so on, like you can see coming up here as well. So 2 corporate sites, same machine, but this is a bit of a throwback going back like 15 years, where this is now static. So whereas we kind of went in that cycle of everyone wanted dedicated, nobody likes SNI, reputation and RBLs and so on. Now I think we're coming to a point where we've got so many addresses, everything can be addressed, and then we can get back to another renewed focus on reputation, and then quite simply look at, well, do we actually need the v4 side? So that's what we quite like about this now, is ultimately the separation that it allows while letting the v4 stay as is for the next while as things keep carrying on and picking up, without having to fully commit and fully change over. You can keep everything running along. Now, we did find recently, doing a bit more kind of tinkering under the hood, if you will, we're working through all of this with the AFNIC TAP crew. We hit a kernel bug in one of the Proxmox kernels. And that basically pointed out, because not many machines hit the problem, that we had some legacy there where a few machines were using an emulated Realtek card. So we've now changed that fully across to VirtIO, which has been amazing. And our decision, whenever that was, 5 years ago or so, to move across to Proxmox has been fantastic. And what I didn't want were routing VMs all over the place and doing dirty things. So the fact we've been able to achieve a really simple v6 deployment is quite amazing, because this is something that we've been asking them for years and years and years, and it simply hasn't been possible. So with all of that done, and like I was touching on before, we sort of stepped back and made sure all sides were covered. So before we jumped in, we got rid of router SB6. Hallelujah. We actually had one problem during all of the rebuild work where we were trying to figure out what was going on. GSL, the transit provider, had said everything is fine. And we were looking through, and Terry was logged in as well. And we worked out there had to be a black hole route for the whole 32 to get anything to head out through BGP across to them. And Terry was looking into this, and this was right around when we just changed to V7. And he was a bit surprised. He went, oh. And he said, oh, that's interesting. MikroTik are actually following the RFC here. Huh. Well, that's different. So then we went and configured everything as we had to. But it's nice to see that slowly heading the right way. Yeah, similar thing with Proxmox with their VMware importing and all the rest of it. And the key thing is that pool testing did not give us any screams from anyone, clients or otherwise. Now, tying back in quickly again to the KISS side of things, we had to follow KISS for cPanel, because for them to approve anything and not have to go up to their overlords, it needed to be simple, contained, and no potential for scope creep. With the network rebuild at the same time, we made sure that the new design was simple, but lets us grow and doesn't get us stuck in a corner, and we understand it. And then with the business side of things, it's really our overall concept of 1% better every day. This is years of work and advocacy coming together because of amazing people like Terry Sweetser, Dave Peel, and Zubair Khan, who've been absolutely incredible. And then through it all, there's always something, and that brings me to my last note, which is about the Dell network operating system. And if I never have anything to do with that system ever again for the rest of my life, I will be a much happier person. What an awful, awful system. Everything's now across to HP with the MikroTik routers. Everything's going nicely. And thank you.
Okay, thank you, Luke. I'm sorry for the voice quality, but if you have any question, you still can ask from Luke. Hearing none, thanks again, Luke. And as we already finished all the discussion for the section, I would like to invite you to give you a big round of applause to all distinguished speakers. Okay, thank you very much. Thank you for your participation. I conclude the section is finished. Thank you very much.